Hello, 30-1s. In this lesson, we're going to complete our transformations of sine theta and cos theta. So we're going to add in our translations, horizontal and vertical. Now, adding in simply these two things will make this more difficult. What I want you looking for as you're doing this is the patterns that occur in these periodic graphs. Those patterns will make graphing these functions a lot easier. Recall from last lesson the basic sine theta graph. By now, what would be really important for you to know is where we created this from, the unit circle. So remember, sine theta is our y values as we go around our unit circle. It would be very useful for you to know the basics of this graph. So when I say the basics, I'm saying my theta intercepts. I should know halfway between my first two theta intercepts is a max, and halfway between my next two theta intercepts is a min. And after that, friends, you can really draw the graph. And that's the pattern that I'm looking for here. So that's going to help us when we go to transform these things fully right now. Because what we're about to do is take this graph and transform it completely by doing things like this. Something like that. Okay, so these things are going to get a little bit more complicated. We're adding in this C and K. Why did I put a K? A C and a D value. We're going to start shifting these things horizontally and vertically. Now, we call this a horizontal translation in our transformations unit. A lot of time when we're talking about waves like we have here, you'll hear this referred to as a phase shift. And this here, this is our vertical translation. But again, when we're looking at sinusoidals, you could hear this referred to as your midline, your median line, and you may hear me refer to this, especially when we're in an application question, as my average line. It's the average value of the graph in terms of the y values. Okay, here's what we're going to do. We know how the phase shift works. It's going to move us left and right. And we know how the D value is going to change our graph. It's going to move us up and down. We've done that before. Here's what we're going to do. We're going to jump into a full question. We're going to transform an entire sine function and graph it. Let's consider this function. Y is equal to 4 sine 2 theta minus pi half plus 1. What we're going to do here is we're going to graph this thing on the grid above. And while we're doing it, we're going to answer all the questions below in back before we graph it. So let's take a peek at this thing. First thing I'd like you to recognize, going back to our transformations unit, is this isn't factored in here. The first thing I want to see is that this is factored. So that's what I'm going to do first. So I'm going to factor out that 2. I like to use brackets for that, and then parenthesis minus pi quarter plus 1. Now that I've drawn this in factored form, let's go and answer all these questions below in black before we start trying to draw anything. Again, it's like describing the transformations to myself. Okay. Amplitude. Well, amplitude is my A value. So my amplitude is 4. Remember that our amplitude is always positive. It's never negative. Amplitude is always positive. Okay, perfect. Now, midline. My midline is my D value. So our midline is 1. That means this entire graph has been shifted up 1. Period. Remember 2 here, our B value is not our period. It's our horizontal stretch. So the little formula that a lot of people really like, which is not on my formula sheet, is 2 pi over b. So I would say period is 2 pi over 2, which is pi, which makes sense. My original period is 2 pi. So if I horizontally stretch by a half, my new period is 1 pi radians. Okay, maybe I'll even put radians there. I like to write that. Phase shift, this is the new part today. The other way to say phase shift is horizontal translation. So we're going to move pi quarter units to the right. There it is. Okay, what's our domain in our range? Well, our domain is going to be infinite. It's never going to stop. Our range, well, maybe let's stop here for a second and let's go and start to roughly draw up what this graph is going to look like. So scroll back up here. And here's what I'm going to do to draw this thing. It's really nice when they give me a grid like this. Sometimes they don't, so you'll have to figure out the scale yourself. Here's what I'm going to do. Let's change to pretty pink. In the order that I would like you to do this, which I think is the easiest, I'm actually not going to go A, B, C, D across my parameters. I'm going to start with D. Here's why. What that does is it gives me my new midline. I'm actually just going to draw that in. It's right there. That's my D value. Then what I'm going to do is I'm going to skip back to my A value. That's my amplitude. That tells me how much I'm going to vary from my midline. Well, that means I'm going to go up 4 from my midline. Well, that's right at the edge of this graph that I've built for you here. That's my max of 5. I'm going to go down 4 from my midline. That puts me at right at the bottom of my graph. How convenient. Okay, if it doesn't fit on the graph your teacher gave you, well, maybe you're doing something wrong, right? Okay, so doing that, sketching that out right away helps me answer what's my range, which is a very common diploma question. What's my range? -3 to 5. Just like that. Now that we found all that, now what we're going to do is transform just a few points on this graph, and from there we'll use our patterns to help us draw the rest of this curve. The points I'm going to transform are these original theta intercepts right there. So 0, 0, pi 0, 2 pi 0. How am I going to transform those points? Well, I'm actually going to go back to a very useful skill we learned in transformations. I'm going to make a map. So our map, we're going to go theta y is going to become, well, order matters. So let's go in proper order. Vertical stretch by 4, that's our amplitude. Horizontal stretch by a half, that's going to affect our period. The phase shift of pi quarter units to the right, up 1. This is our map. Now what I'm going to do is I'm going to transform what I believe are the 3 key points. 0, 0, pi 0, 2 pi 0. These are my original theta intercepts. So if I can transform these, you're going to see how we'd use this to help us draw the entire graph. Okay, so where does 0, 0 end up? Well, that's going to end up at pi quarter and 1. That one was easy. It's the next two where you're going to have to do a little bit more work. Me too. So I sub in pi here. So I'm going to have pi half plus pi quarter. And 0, of course, is going to end up at 1. And again, here's your fraction work that you're going to have to do. If you're not a friend of fractions, use your calculator. Just don't put pi in your calculator. And 2 pi over 2 plus pi quarter And that's going to end up at, oh, that looks like 5 pi quarter. Perfect. Okay, here's the points that we're going to use now. It's our new coordinates. This one, and this one. Okay, I'm already recognizing a pattern. Do you see the distance between pi quarter, 3 pi quarter, and 5 pi quarter? The distance between each of those is 2 pi quarter, or pi half. Okay, that's going to be really useful when we're drawing this. The other thing I like about moving these points is notice that all of these points will be on our new midline or median line. All right, let's go draw these and see how we use that to get the rest of the graph. Okay, here we are. So I'm just going to erase these original theta intercepts because they're not important to me anymore. Let's go and draw our new coordinates of those. Well, 0, 0 ended up at pi quarter. Pi 0 ended up at 3 pi quarter. And 2 pi ended up at 5 pi quarter. Okay, notice again this pattern I'm seeing. The distance between all of my theta intercepts has now changed to pi half or 2 pi quarter. Do you see that? So now here's the beauty of this. Halfway between my first two intercepts, my first two midline intercepts, I should say, halfway between my first two midline intercepts on a sine graph is our maximum. So I'm going to come up here, and there it is. I'm going to have a max at pi half, comma 5. Halfway between the next two midline intercepts will be my min. Just like that. And I can already see the basics of a graph showing up here. Look at that. Okay, I missed that point there. Do better than that. Here, I'll do better than that. I was just going to say do better than that on a test. Well, I'll try to do better than that. Okay, little shaky, but you can see it. Now watch, I'm just going to complete the pattern. There's my distance between my theta intercepts, my midline intercepts. Then I'd have a max, then I'd have a min. And there it is. If I wanted to go backwards into the negatives, I just repeat my pattern. And there it is. And it would keep going. Okay, now if this was on a test, I would I would draw it so I wasn't a little more concave there. I got the coffee shakes, but it would look a little prettier than that. There it is. Do you see how we use the pattern of our midline intercepts to find the rest of the points? That was it. Label those points just like I did with a nice dot. That's it, friends. That's how we're going to draw these graphs. Okay, that's awesome. We drew that by hand. But I have this amazing thing that someone bought for me called a graphing calculator. So let's go check our work. Here's what we're going to do. We're going to grab our graphing calculator. First thing I'm going to do is I'm going to make sure I'm in the right mode. I'm in degree mode, so hey, good thing I checked, right? Radians. Okay, I'm going to go to y equals. I'm going to punch in our equation here. So let's clear this out. 4 sine, and I'm going to use the original equation, not the one I came up with by factoring, because what if I had screwed up my factoring? This is going to be a bit of a check for me, isn't it? Okay, so here was the original equation, plus 1, like that. Now, before I go and hit graph, I'm actually going to do 2 more things. In y2, I'm going to draw the equation of my midline. It's at y equals 1. You'll see why I did that in a moment. I'm going to go to window settings. I'm still in degrees here. I'm going to switch it. So, but I know there's zoom trig, friends, but I don't like it. So I'm going to go negative 2 pi to 2 pi. But here, this is the other important part. I'm going to change my scale to be pi quarters. Why? Well, think about where those 3 points we transformed were. Pi quarter, 3 pi quarter, 5 pi quarter. Oh, okay. Y min, well, I'll just go to -3. I believe that was our minimum, and Y max was 5. So now what? Watch what happens. I graph this thing, and yeah, it looks like a sine graph. I can't tell if I've done it right or wrong, but when that midline comes in, I can tell that I've done this correctly because I can clearly see that my midline intercepts are on the first tick mark, which is pi quarter. My next midline intercept is on the 3 pi quarter, the third. My next midline intercept is on the 5 tick mark. I can see my max is at 2 pi quarter up here. I can see my next min is right at pi. By graphing that midline and changing my scale, I can tell that I've done all these graphs correctly. So there it is, friends. There's our graph. It matches what I've done in my calculator. Your job now is to go and practice doing some more transformations of these with sine and cosine. We'll talk about the transformations of tangent in another video. We no longer transform the graphs of cosecant, secant, or cotangent. Trust me when I say you are very happy about that.